current package, and let's just start pounding it. So, yeah, anyway, so that would do, yes, I should fix that. It would basically simulate, right, like a bunch of REST requests coming, and then it would show the predictions. Saying those top 10 confidence, right, like 0 through 9, which digit is predicted. We can do, because the REST APIs, or the command lines a bit busted, let's use the REST API. So that's a sample image, and these are the outputs. So that's what the CLI would have done with it like 100 times. Okay? So now this is all locally. And so from this point, what we can do is then push it to our Docker registry or put it through some CI process or some, what we've seen people do is it goes through security and gets scanned and all that kind of stuff. But now let's do one other thing. So I promised you guys that stuff would start showing up in dashboards. Here's that same. Do this a bunch of times. We can see this thing light up. So normally, if I could do the 1,000 rather parallel requests, this would be a little bit more exciting. So that's that. And then one other thing. With a little bit of shimmying, you can actually get Grafana working. So Grafana is running inside. Right? So this is like a development flow, just to show you guys what's all possible here. But you can actually, so we're using Prometheus, right, like beneath the covers, but we also support Datadog and all the normal ones. But yeah, you can actually build custom dashboards here and create those things I was showing before. So this is kind of the standard one, request per second. And then there's where like time is being spent. So this lets you from like one single Docker image actually do all of this debugging locally. Okay. Then we want to stop it, so just use more resources. And then let me show you guys the SageMaker thing. So think of being able to do all this stuff, so now there's this Docker image that you've created, you've debugged, you've like performance tuned locally, and now you want to so put this out. Oh, so normally what we had been doing up until last Wednesday was we still of course support this is Kubernetes. So here's like version 1, version 2. Yeah, this is like just a view here. So this is a server I had running out in Amazon. It's a GPU server. It actually powers our community edition thing, which is just a Jupyter notebook with access to this GPU. And then here, okay, so this SageMaker thing. Let's go into here. Right, like I don't work for Amazon or anything. There's no interest here from that standpoint. But this is Databricks right here. Boom. That's what like 20 developers over 3 years spent.
So AWS OEM, is that from Databricks?
No, yeah, Databricks has nothing to do with it. It's just kind of a mockery of, yeah. I mean, I'm sure it took Amazon at least 20 developers to build this whole thing. And so you can actually select the type. So this is where you can select GPU. Here's the P2. Looks like they don't support the P3 yet on the training side. Probably what's happening here, when you see sort of limited GPU stuff, what's happening is that they haven't figured out the right combination of the Linux kernel plus the CUDA version plus the CUDA toolkit, and they're just, yeah. I'm sure for those of you who have set up a GPU instance before, you know that there's so many little things that could go wrong, and if you're reading someone else's blog post and following along, and it's not working for you, as you start thinking, yeah, this person's a bozo, yeah, I don't understand why he has 1,000 views on this thing. It is almost always because at that point in time, they were pinned to a version of Ubuntu or something that was one particular kernel version. And these cloud providers are constantly updating these kernels for like security reasons, performance patches, things like that. The newer version of the kernel yes, by default, yeah. So that's what you're getting, and you're trying to run something that was tested on an older kernel version with an older CUDA version, and things like that. So one thing I've had to do for the workshop specifically, this burned me. I think I was in like London or something. And I got pinned to lower. Yes, I got pinned to like a different version of something, and I didn't realize with these cloud providers that you could actually specify a version in time for that like AMI, right? So by default, if you just go and say new and pick an Ubuntu 16.04, it's just going to give you the default, which is the latest. If you're using command line, you can actually get to the specific kernel version that you want. That was a checkpoint in time. And yeah, so they'll eventually roll those off, every couple of years. Yeah, so just know that when you're trying to set up GPUs, especially with Kubernetes, it's like near impossible. You'll lose family members and all kinds of stuff. But so what's cool here is that you can create IAM roles. You can deploy these into specific VPCs that have access to specific resources, right, like Kafka topics, things like that. This is for the notebook. This is just like notebook stuff, so it's not all Apache. What you end up getting is something like, so here I'm using Jupyter Lab, which is like a newer version. It's a skin on top of Jupyter, but you would essentially get Jupyter Classic here. And it would have, I think by default, you get TensorFlow 1.4 with Python 2.7 and 3.6. You get XNet. So basically, what I think they call it, it's like the Amazon like deep learning AMI or something as, and yeah. So there's different profiles for these things. So here we can also do training jobs. So here I was actually doing distributed training. I was trying out TensorFlow like distributed, which is like pretty much near impossible for us mere mortals to get working. Even with Google Cloud ML Engine, follow the examples, and it still breaks. There's some parameter that they added or that is like misdocumented. But yeah, this actually works pretty well. So if you're using the TensorFlow or the Estimator API, which if you're starting right now, use the Estimator API. If you're not, what's going to happen is that there's so much rather innovation and so much effort going into that single API. And actually, I have some like slides on this. But why it's good is, so when TensorFlow first came out, it was very linear. It was very top to bottom, right? And so at first, right, like there was no distributed TensorFlow. It was literally this is a single node TensorFlow, and people started to compare it to Caffe and local scikit-learn, and they claimed it was horribly slow and all this stuff. But the real power with TensorFlow is distributed TensorFlow, and at training time, the ability to split up. So the first like examples that you saw didn't have really distributed TensorFlow in there, and specifically this Estimator API, which is that paper I was reading recently, which talks about training to serve. So with the Estimator API, they split out like pulling in data. It's sort of like callbacks. So it's not just a flat sort of linear training process. It's if this node, it's kind of more Sparky, right? Where each node kind of gets like a snippet of code and it pulls in its own data set and can deal with all of that. Those different partitions and things like that. So so what was really interesting was that really no one's gotten this stuff to work in the mainstream. And then at like reInvent, of course, they announced the SageMaker thing, and it has tons of examples of using TensorFlow distributed and things that you wouldn't see on that. Okay, so we got 10 minutes. Here's more on the serving side. So when you train, you could actually, like one of the things you could, so this is where you create training job. You would put in your job, you select this. So this is where you would select, they kind of have, so this is the old sort of Amazon like ML service that nobody used. It was super exciting. Yes, I remember being at Databricks. I think it was the Amazon Summit in San Francisco, and I was at the booth working Databricks, and they had announced, this is Amazon had announced this like cloud ML service. And people were freaking out, like we were shitting our pants, like, oh my god, what's going to happen to data? Right? And so they're sort of repackaging all that stuff into this slick new way. But now this is where you really want to be, which is this custom thing. And so this is what gives you the ability to upload or to specify a training image. And so so before, the things that I was uploading, I think was just the like predict side of things, but like you could actually upload yeah, so here we go. So this is actually hitting SageMaker. It's pretty much the exact same image, just a different tag. One thing you'll notice is it's showing which variant. So so these variants will make sense here in a sec. When I finish. Okay, so here we would create the model. This is where you would create 2 different versions with like 2 different, this tag would be like E1 or whatever. And then you go over here, you at some point get to this common endpoint. So that was the name that I screwed up the first time and did predict name. So let's see, if you click on here, it'll show you that this is in service. Here's the REST endpoint. The goofy thing here is like Amazon and all their security and everything. You have to have X519 crap. So it was much easier to just do it through the command line with Boto. But this would be the actual physical REST API, which I know we're all excited to see. But it's not that easy to hit it. And these are the variants. So if you notice, there's V1 and V2. I was going to try to go through and set up A, B, and C, but not time. Those are the variant names, and that's physically what's coming back in the response table. So you can see, here I have equal weight that's being assigned to them. But if you want to, skew it, but if you notice, right, like when you set up a variant, you actually can select the type of the EC2 instance as well. Existing config. Okay. So similarly, with I think how to So this is the like Istio stuff here. I think I have a dashboard. Crazy though. Yes, I was going to show you guys spraying traffic across. So this would be the Kubernetes view, right? Like this is essentially the direction that we started at for services like Google Bottom. Yeah, I think that's it. 45 minutes. Good job. I'll post the slides here. I have to clean them up a little bit. Here's the performance comparison between the P100 and the V100, and this is specifically focused on the floating point 16. So for the half precision, right, these voltas blow things away. They just completely blow it out of the water. Because of these tensor cores. So I mentioned earlier that the new Volta V100 has specific cores to do this operation. A times B plus C, or right, like M times X plus B. Yeah, so when possible, get the Volta. It's a TPU graph here at Google. If you notice there's an AlphaGo sticker on the side there. Yeah, any questions? Go on. Oh, so one thing to show too, this is, yes, I asked for questions and then I just talked about it. There's this new dataset API that is starting to actually get documented. This is where you see TensorFlow merging towards Spark. And yes, as we all know, Spark is trying to become less Hadoopy and more AI-y. So you see Spark starting to introduce, of course, the image classification, transformers, things like that, right, like estimators. But so this is TensorFlow going the other way. And they went straight to dataset. If you know anything about Spark, hear dataset, you kind of cringe because it was first it was already data, it was data frame. So yeah, you wonder if they're going to change the name. There's some really cool stuff. If you're not using dataset APIs, it's very similar to the estimator API, or my warning about the estimator API that you should be using it. There's a lot of innovation going into this dataset API that's happening behind the scenes. This is Google's showing that TensorFlow is faster, not because of the numerical processing necessarily, but because they can get data to the GPUs faster. And yes, all of this research, there's a ton of stuff. This paper was out of ICML 2 or 3 months ago. This comes out of Google Brain. It has Jeff Dean's name all over it. And so this is like various placement strategies. So like this is a little bit broader than just data set API, but this is so like during training, right? Like using so like figuring out on these super large clusters based on the current conditions, right? Like based on network conditions, based on servers dying, things like that. Learning techniques, sort of explore, exploit, right, kind of thing, to actually place operations. So if you're sort of just naively placing operations, right? Like yes, operations are like a matrix multiply, something like that, on a GPU somewhere, right? But that might not always be like the fastest way based on sort of empirical. So these are long-running jobs. These aren't the ones that. Things. So here's the estimator API. There's also this thing called the experiment API. And so this is one of those APIs that you could tell came out of Google's product management group. Because on the actual Google Cloud ML UI, which is kind of similar to SageMaker, there's, the main domain object is called an experiment. And so this experiment thing didn't really, it's separate from the estimator. It's kind of a higher level concept than the estimator, right? Like, so we would be focused on like the estimator, and then someone else could be cobbling together different models to create an experiment. This is where the hyperparameter tuning comes into play. Yeah, so this is where like a lot of things are not very well documented, which is kind of weird because you have to imagine people are actually using Google Cloud ML, but they must just be holding specific customers' hands or something like that. It's not public documentation for the most part. There's all these weird config files, and with like hyperparameter tuning, you're giving it one variable that's saying test like a range, and there's this little syntax you can use for that. So use estimator API. The estimator API supports Keras, so you can actually convert. Something else you start to notice here too. Oh, yeah, this is worth mentioning. There's these canned estimators, and that little thing up top is kind of inverted in how I'm going to present it. But 42% of Googlers internally are using, so they're not using canned estimators. So said differently, 58% are using canned estimators. So these are first-class citizens within the TensorFlow API. These are really well-tested. These are common, CNNs, DNNs, things like that. There's this tensor forest thing that's kind of funny. And so what they're saying is use these canned estimators as much as possible, because if you start to veer off and create your own, like there's a lot, there's a lot of complexity inside of these estimators. And it's just, pre-packaged code, and then you just give it hooks to get your data in. Most of the tuning I do these days is just sort of optimizing that pipeline, right? Which is why we call PipelineAI. But it's like figuring out the data set API, right? Like ways to get things to that GPU. One thing, this is worth like highlighting, I mentioned this earlier, that there's starting to show up some TPU-specific things within TensorFlow. Now this is in the contrib package, which would be not sort of mainstream, but this is specific code that kind of breaks the mold a little bit. And there's this cross-shard optimizer that no one can really figure out because no one has access to these TPUs. That's what you actually wrap the like traditional gradient descent optimizer, and it does some TPU magic. So keep in mind. Also, this is a pretty cool concept. This is I hadn't really thought about this or experienced this like before, but this concept of multiple heads, and heads are multiple predictions, and heads, so things that are in the traditional courier fonts, are actually from the API. So head is actually part of this estimator API that you'll start to inherit if you're using estimators. And what's happening here is so traditionally you're going through and making a single prediction, but now you're actually making two predictions, or said differently, you're making one prediction, but then a second head is just to retrieve that final layer, right? So this is a numeric representation of that single image, for example, right, that went in. And so why you would do this is when you're starting to ensemble or starting to compose, right, these different neural networks. So now you're actually treating this neural network as a feature engineering step. So it's making a prediction and saying this image is a penguin, but it's also giving you back that final layer, which is a numerical representation that you can then pass into a second model, which will make a prediction, and then you can get the majority or do whatever sort of ensemble. Actually, so this is, so like Keras has this sort of functional API. This is probably getting a little too crazy, but there's this like normal sequential API and then a functional API. And this functional API starts to give you the ability to do this composition, right? Like that's what functional programming is all about, composing. And so this functional API within Keras is starting to make that more accessible. Just a couple more slides. Here's the ExcelA stuff. So this is the intermediate representation. This is, like again, logical query plan to physical query plan. The syntax is actually called HLO, high-level optimizer. There's a ton of documentation. What's interesting is that this like TensorFlow project, specifically the ExcelA stuff, has a whole lot of documentation for hardware people to tap into. So, right, like hardware people want to come in after it's been optimized, you know, sort of logical optimization, and then anything target specific. So right now they use LLVM to get to that sort of last mile because there's tons of support for LLVM, like project out of Apple. And yeah, there's actually NVPTX, which is the GPU. Yeah, that's the instruction set. So that's all good. And then here's the JIT compiler, which is built on ExcelA. So similar to Spark's project Tungsten, it's fusing. So as training is happening, yes, these are the things on Saturday and that are in right, those like GitHub repos and these notebooks that are all public. Yeah. So we'll actually do this. We'll actually turn on ExcelA. And as training starts to see more and more operations and things that can fuse together, it's going to start to fuse them together. And the whole goal is to achieve this. Profiling the GPU, and that's before ExcelA is turned on, and there's 15 operations that are happening on that GPU. So this is memory that has to go from the CPU into the GPU. It's operated on, goes back, it might get flushed to disk, rather depending on how it's implemented. And so this is after ExcelA is turned on. This is after it's been running for a little bit. It can actually fuse those 15 operations together, move that memory over once, make one big calculation, and then send it back. And there's a lot of support for this, again, for the hardware people that are implementing. Yeah, so one thing I finally figured out about Google and about their strategy is it's probably 70% they're like Google Cloud. But there's this big push to really go for the hardware people. And if you think about it, that's kind of where you want to be, right? If you can sort of control and get people to hop on board from a hardware perspective, that's where the real scale starts to happen. So we'll actually do two minutes. Here's that AOT thing. Oh, sorry. This is actually the TensorFlow Lite. So this slide has TF compile on here. You can still actually do this. It's similar to that TensorFlow Lite thing where you give it a graph, which is your train model. So now this is all post-training optimizations, right? So ExcelA, but this is where it starts at the input and goes to the heads and strips everything out and just pulls in from that TensorFlow Runtime, just the kernels that are needed, the operating system kernels as well as the TensorFlow kernels. The output of this is a CC or a object file and a C header file that then gets linked in. It's 70K versus what would normally be 50, 60 meg at runtime. So this is where you start seeing there's no GPU support. So even though it's based on ExcelA, there's not much effort going in. But I'll bet you anything that there's definitely GPU support, especially because of the mobile aspect here. One last big post-training thing that we'll cover on Saturday in depth. Yes, I should also mention, I keep mentioning Saturday, I've posted the last 4 or 5 workshops from even as recent as last month. So if you can't make it on Saturday, just go. PipelineAI and click the link to. So this is the graph transform tool. So let me show you guys. Yeah, so this is where you can do quantization and all kinds of fun stuff. And so this is linear regression. So this is right after it's been trained in TensorFlow. I think there's 84 nodes. So it's crazy like this. Yes, even though at like prediction time, it's just 5 nodes. Or like, yes, these neural networks just like want to be trained all the time. They hate going to production, right? Yeah, they're kind of like grad students. They just kind of like to sit and like stay in the research lab and just have people tell them what to do. But what we want to do is get this right, like down to that before we actually serve it. So TensorFlow is building in some of this, right? As you can imagine, but it's still not good enough sometimes. So there's this C++ binary that when you build TensorFlow from source, which we have in the Docker image on Saturday, yes, we could actually start to shrink this down and do quantization in full. Yeah. What you want to do then is freeze the model. So I want to mention this because you'll see this quite a bit in like documentation. What you're doing is probably telling that grad student that this person can't go back into the lab anymore, that they have to actually interact with people. And so it's really burning these variables, or it's taking these weights and then burning them in and making them constants. So yeah. So it's actually going to create a separate like binary that then gets served up by TensorFlow serving. But that grad student still lives. You're just cloning the grad student. I think that's it. This was from a text. And my old roommate was explaining this to me like a bit ago, how the linear algebra part works when you do the request batching and batch up, wait 10 milliseconds or 50 milliseconds, batch up all of the matrices and all the vectors, pass it to the GPU. Because of the properties of linear algebra, and because we control the offsets, on the way out, we could just split it back and send it back to the 2 different polymers, which could be. And that's it.
So maybe we do a couple of questions and then we can wrap up. Just can you a little bit here?
Yeah.
So
Yeah,
I
can talk.
Yeah, man. I mean, this is all I've done the last year, right?
I saw your talk 2.5 years here on
Here?
Open Data Science Conference in Boston.
Oh, cool.
And you was in the Meetup before, like.
Oh, the one at Spotify or Echo now?
It was same style, same 150 slides.
Oh, like totally different material.
But it was about Spark.
Yeah, no, I'm so sparked. It like hit me one time. I was speaking at somewhere. I was like, I can't even say the word.
any other questions?
So the PipelineAI framework seems really cool. Does it handle like deploying out the Prometheus and the Turbine and all the other?
Yeah. So the cluster capabilities are what like the investors want us to hold.
I see.
So what we keep going back and forth with these people is we need you to get to a point where you feel PipelineAI is worthwhile. And so we made the decision to jam-pack one Docker image with all that because you can get a taste for it.
Right.
Yeah, and obviously you would need to.
So along that line of questioning, does the sampling screen where you can see the minced characters and then the results, the classification results, does that have a versioning scheme behind it to tie to a specific Docker image? Like, can I look historically at what it was doing before?
So these are all real-time dashboards that we have. So this is data coming in right now. But yeah, you're saying like later on you want to analyze. So we're powering that dashboard from Cosmos. So yes, that data is there. It's just up to you. Yeah.
It's a window or?
It's a window. Yeah. And so we, there's one way that like we can, I mean, this is all business model kind of stuff that I've been dealing with investors. One thing we found is if we bring in too much, like the ops guys get all crazy, but if we don't bring enough, then we're not valuable. So we're trying to find that balance. So one thing that we're really sensitive to is hooking into people's existing infrastructures. So, right, like the way that we demo it and talk about it is one way, but the way that it's really implemented, yes, it comes down. I mean, right now for the early beta customers, it's been so customized because we've essentially been like building a lot of these.
Reiterating.
Sorry?
Sorry, go on.
Yeah, and I mean things like the Datadog integration and some of these use cases popped out of that. But in some cases we have Mesos, many people are using it. And so the challenge is trying to stay generic enough that we can. So we prefer Kubernetes. One thing I realized pretty quickly is we started to treat this whole system like a black box and not really talk about Kubernetes. Like at first, that's what we all think about in school, like all of us. But if you, I was talking to like Twitter Cortex recently. I spoke over there, and I could see people's heads just tune out when I mentioned Kubernetes. So, because they just don't think it's even viable. So we're kind of at the container level. And so one thing that the SageMaker thing really, right, like some people say, oh no, Pipeline has no future now in SageMaker. I actually feel good about SageMaker because that's all the crap I didn't want to worry about anyway. And there's so many customers in that sort of middle area that aren't like Twitter and aren't like Netflix that don't want to deal with custom infrastructure. Don't want like they're fine with like an Amazon black box, but not PipelineAI. You're catching me as we're going through this. So.
Thanks again, please. Appreciate it. So I say happy holidays, guys. Hope you have a wonderful holiday. I think you should stick around to guys can talk to them. And feel free to hang out. I think until Ben or Lauren go to you. But hang out and take care. Thanks, guys, once again.
Yeah, here's the code again for Saturday. 2 bucks. We edit out all the